Oh, hello there, Internet and you amazing creatures of the beyond. Hope you are all doing great today. So, recently I had a discussion with somebody about the creation of the universe. And we reached a point where we were discussing about entropy. So, a lot of people heard about this term, but most of them do not understand what entropy means. The term of entropy comes in play into the thermodynamics laws, and there are four of them. And we can kind of visualize entropy as the energy inside of a container. For example, let's say boiling water. And once the boiling water stops boiling, yeah, you remove the energy source, then entropy starts raising up because you're losing the energy from within the container, the heat, and it radiates out. So then that means that the energy is destabilizing. So the same happens with the creation of the universe. Once the universe was created, the Big Bang, everything was so dense. And once then the universe started expanding and the galaxies started going further and further away from each other, so does the entropy raise. So entropy goes only in one direction. It's only growing. And basically, entropy can be translated to disorder. Um, and it becomes less usable energy, in other words. So let's talk about the rules of thermodynamics. Thermodynamics comes from Greek, which is composed by two words, thermes, which is heat, and dynamikos, which doesn't mean dynamic but means powerful. And thermodynamics is a study in physics which um, analyzes the relationship between temperature, heat, and energy. And the first law of thermodynamics states that energy can be converted, it can be transferred between various objects, but it can never be lost. Uh, Second law of thermodynamics states that if two systems are in equilibrium with a third system, then all three systems are in equilibrium. So if 1 equals 2, 2 equals 3, then 1 and 3 are equal as well. I'm talking about the systems. Third law of thermodynamics states that the universe tends toward entropy and it can never go into the negative value. So, as I said, it tends towards disorder. And the fourth law of thermodynamics states that once a system um, tends towards entropy, its temperature also reaches absolute or approaches absolute zero. And absolute zero is a specific value of temperature in physics. So yeah, it's it's a very interesting thing how entropy works. And basically, entropy is the reason that life exists and that all of our electronics works. Because let's think about the sun. The sun gives us energy, but that energy has to be spread out somehow, because if all the energy would be focused on earth, then the temperature would rise too much and it would be impossible for life to exist. But we have the atmosphere around earth that takes part of that energy from the sun and extrapolates it towards the other side and spreads it in the universe. And then all the energy that is trapped inside the atmosphere starts to be, well, manipulated. So heat is transferred through objects, So it is absorbed by objects, then heat can also put in motion various currents. So heat is not static in this case because it becomes as a flow. So once we circulate this heat, it makes everything kind of alive on the planet. I don't know how to put it in other words. So yeah, uh, that is my short introduction to physics. I'm not a physicist, but these are just like basic things, basic knowledge that we all learn through school. And when we look at it, we have to understand that even though the universe is crazy and wild and in full motion, what seems like a destructive force is like a phoenix, you know, everything that gets destroyed uh, creates something from its ashes. Even like a forest, for example, if a forest burns down, everything that remains behind, the ashes and the charcoal, fertilize the earth in order for the next generation of a forest to grow even more lush and stronger because of the sacrifices of the trees that have been before it. And the same happens to galaxies. Like there were many early stars in our universe that were very bright and very powerful, and they were burning super fast. Well, fast is a relative term because they were burning over millions of years. But the point is that our sun will hold for around 4 billion years or something like that, while everything else kind of burned extremely fast. So the more a star grows, the faster it burns its helium, and then, well, in case it has helium, of course, and then um, it explodes. It creates supernovas, quasars, and so on. And all of these explosions create all the elements needed for them to be recycled and create new material and denser materials. And the more these cycles happened over the eons, the more heavier elements have started appearing, such as iron, gold, and so on. And these things started accumulating, and since when gravity came into play, it started clumping all of these elements together, and the more it clumped, the more dense it became, and then the cores of planets have started becoming a thing in motion and accumulating more matter around them, such as rocks and debris and etc. And planets came to be, and many other interesting cosmos bodies out there. So the world is all about motion and the transfer of energy. And we can kind of visualize this like the Big Bang when it first happened. It was like us throwing a rock in a still pool. The pool has no ripples, but when we throw the rock in, the pool starts rippling in all directions. So this is what kind of happened with the Big Bang. It um, destabilized this uniform field, and thus we came to be. Of course, this is just a over ultra simplification of how all of these things works, because of course there is so much more going on into the field of physics and quantum mechanics, and it's impossible to just put it in one small session. Have mathematical systems that prove how they work in principle. Of course, we are not there to see them with our own eyes, because let's be honest, we barely comprehend that black holes exist right now, but we don't know exactly how they work and what happens inside them. We kind of know what happens outside of them, but and we kind of know there is heat happening outside their event horizon, but we don't understand what happens with all the energy that falls inside the hole. We know that it can be thrown out back, but again, we can never understand until we have better better science developed and better tools, and who knows, maybe we'll one day send rockets inside or probes to see what happens to them if we can maybe contain that signal between a satellite and the probe that goes in. Of course, the event horizon crashes and destroys everything because it has extreme heats, and then it elongates everything like a spaghetti inside, as we have seen in movies. But it would be cool. It would be cool. So yeah, you guys stay awesome. Always investigate your curiosities, and catch you in the next episode. Bye 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 bye.